we'll talk about HTML5 and Flash video today. I have worked on this presentation with a couple of my colleagues from YouTube, Greg Schechter and Phil Harnish. They're both software engineers on HTML5 and Flash, respectively. If you would like to tweet about this session or otherwise comment on social media, please use the GDD11 hashtag. Here's the agenda for today. I would like to speak about what are the differences between HTML5 and Flash video, what are the features that are important for us at YouTube, and how that translates into user experience for our users. We will touch upon device support. So HTML5 video is still relatively new. It is getting a lot of adoption, but I wanted to share some information with you from our perspective. What's the HTML5 support like? We'll speak about performance. So we ran some benchmark with our Flash and HTML5 players, and wanted to share some data with you so you kind of have a better understanding of how video performs across various browsers with our player. We'll talk a little bit about the embed API. So as you know, we offer an API that allows you to customize user experience. So you can actually script the player, build your own user experience around YouTube video. You don't have to use our control. You don't have to use our color scheme. You can do things the way you like it to be. And then we'll have a short Q&A. So what's HTML5? I think all of you guys probably know. JavaScript, CSS, awesomeness. I mean, that's what we like about HTML5. There's several features that we find particularly interested for us. So the ones that really stick out are all the multimedia related features that HTML5 brings. So in summary, from our perspective, HTML5 looks kind of like this. So unicorns and rainbows. That's a summary of this presentation here for you. So the question that we had on our mind when we started working on this is Flash has 99% of desktop penetration. So really, why bother, right? I mean, it's there. It works really well for us. What's the purpose of getting into yet another video technology? So we look at several aspects, and we'll kind of walk through them one by one. We'll look at the feature sets, what's in HTML5, what is not in HTML5, and how this relates to our requirements. We'll talk about accessibility, which is important for us because we do have users who have disabilities, and we want to address these as well. We'll talk about deviceability, which is a term that my colleague Greg invented. It really has to do with the wide device support for the respective technology. And that is especially important in the mobile world. So we see a tremendous growth in mobile video consumption, primarily driven by social media. So if you get a tweet or update from a friend of yours with a video link, people typically click on it right away, and that brings up a mobile YouTube player or YouTube embed on the mobile device, and that is driving a lot of our growth. We'll talk about some of the security requirements that we have around content. Remember, YouTube is a technology company. We stream content that we acquire from our content partners, and we'll chat about the API. So you might have seen this chart before. It's available on html5readiness.com. It really tracks all the various HTML5 features and the browser support. And as you see, it's actually filling out quite nicely. So you have more and more browsers supporting the full spectrum of HTML5 features. So that is good. We like that. And however, there's still features that are actually missing in HTML5 from our perspective. And again, we are a video site, so there's a lot of video-related functionality that we would like to see in HTML5, and it's not quite there yet. Starting with content protection. So some of our partners require that we actually protect the content and encrypt it. So Flash offers RTMPE and Flash Access. So these are the DRM-related technologies that allow you to really secure the content. Another one that is quite important is camera and microphone support. So on YouTube, you can actually record a video directly from the site with a little widget and upload to YouTube. So this is something that would be rather difficult to do with HTML5 today. Full screen video. So CAD videos look really good on full screen, ideally accelerated in hardware. And this is where HTML5 has been a little weak. This is changing. There is actually a WebKit support right now for JavaScript full screen. And here's what it looks like. So you can actually call WebKit request full screen on an element, and then when the element transitions into full screen, you get a callback. So this is something just getting introduced into the major browsers. I know we support that in Chromium already. There's still some bugs around it, but that's going to fill a major gap from our perspective, since we do like full screen video. Format support is another thing that it's somewhat difficult to do in HTML5 in a portable way. Today, some browsers support H.264, some support WebM, some support both, and this is where there's a little bit of fragmentation. And later in this talk, I'll show you how we're actually dealing with this. It sure would be nice if all browsers supported the same video format. So this is something where on the Flash side we don't have to worry about. On the HTML5 side, this is still a reality today. And consistency in behavior. So if you write a Flash app, typically you don't have to worry too much about different behaviors on different platforms, because the plugin takes care of that. With HTML5, it's a rather different story. So the things that we like about HTML5 is that pretty much you can get everything in open source. So you have complete stacks, starting with the codec. So WebM is actually open source. You can download it. VP8 is open source. The player and the browser itself. So there's a number of open source browsers. So that really allows for great integration and lower latency. So one of the numbers that I'll go over with you a little later is how much time does it take from the initial page load to thumbnail when the user actually sees the embed. Because for us, user experience is very important. Every millisecond counts. So ideally, without a plugin, you wouldn't expect the latency that necessary for plugin instantiation. So that's something we like about HTML5. And consequently, the latency translates into better fidelity, better performance, also because of the vertical integration. So some of the features that, for example, we've been rolling out lately on YouTube require very tight integration across the entire stack. So from the player, plugin, browser, hardware. So namely, all the things that are hardware accelerated, for example, 3D video playback, or just video decoding. In order to really take advantage of the underlying hardware, everything has to work in concert. And the more layers there are, the harder it is to get it right. Accessibility, I mentioned earlier, this is pretty important for us. And the reason why it's important, because we want to include captions on cat videos. That's not really necessarily true. What we find is that for those of you that actually have played with our Flash player, you will notice that in the Flash player, it's a little difficult to tab your way around if you navigate into a video. I'll show you what I'm talking about. So say I can tab my way around for accessibility and use the keyboard controls, but I'm kind of stuck here. I can't get out of the Flash player without using the mouse. And if you look at the equivalent HTML5 video, so this is actually running our HTML5 player. I can tap into the player and then get out and continue tabbing. So that's where accessibility is important for us, and interestingly, HTML5 actually has a clear advantage here. We talked about the features. So another thing that is important is this term that we put together, deviceability. So it really has to do with device support. So for those of you that have been following what's been happening in the mobile world, you see that not all platforms support Flash. And this is kind of started with iOS. I think recently Microsoft, I heard, is doing something similar with their Windows 8 and Metro. So what we see is that on YouTube, majority of the access actually originates from browsers that do not have HTML5 support yet. And then among those that do, Chrome has been leading the way, and then the share of the other browsers is growing. And we also have a mobile population that uses YouTube using browsers that don't have Flash, have HTML5 support. So if you kind of turn it around, the picture looks something like this from our perspective. You know, we have this huge universe of devices that can do Flash, some subset that can do HTML5, and then a little sliver of devices that can do HTML5 only, and they cannot do Flash at all. Now, we looked at, you know, for the devices that actually run YouTube apps of various types and use our API, you know, what is it looking like? And we discovered that a lot of the devices that are HTML5 only have actually very interesting apps for them that use our API. So that was a clear opportunity to actually support these devices so that you know, we could offer video playback, capture these playbacks, and still offer decent user experience. So instead of, you know, why HTML5, the question became when. Really, you know, how fast do we want to roll this thing out in order to recover the playbacks that otherwise would be lost. So that was really the driving goal for supporting HTML5. And the solution that came up with looks something like this. You guys might have seen it. This is the iframe embed. If you look carefully, you know, there's nothing here about the underlying video implementation technology. So, you know, it could be Flash, it could be HTML5, it could be something else on, for example, mobile devices where we might know that this particular device has neither, no Flash, no HTML. We can still do something. And that is really the goal, is to abstract out the video playback technology from the actual embed syntax. So the only thing an embedder needs to know is, okay, what is the video ID? And, you know, given that, we cannot take care of the rest. So what we do is give the user HTML5 or Flash, depending on the video supported, depending on the device characteristics, depending on user preferences. And this also works in the mobile context. So the same embed, if you view that on iOS or Android, you actually see your video, and, you know, it'll just work. At least that's the goal. How do we decide, you know, should the HTML5 video be used at all or not? And we have a little state machine here that kind of illustrates, you know, how the decisions are made. So the first thing we check is, you know, does the browser support HTML5 at all? Now, how would you do that? There isn't really a way to tell if a browser supports, you know, HTML5, because we really detect certain features that are supported. And what we check for is, you know, can you support video element? If you can't, then, you know, sorry, no HTML5. Video playback. Now, if you can't support video element, we actually check for both H.264 and VP8 WebM support. If any of these are supported, then we feel pretty comfortable that there's a chance this browser will be able to play HTML5 video. Now, we have introduced WebM support a while back. Not all YouTube video is available with a WebM yet. The way the process works is when you upload the video, we actually transcode it to a lot of different formats. And then, you know, in the past we didn't transcode to WebM because WebM didn't exist, or, you know, we didn't have control over that technology. We didn't acquire it yet. Today we actually transcoded, and we actually went back and retranscoded some of the old content to WebM, but not all of it. However, at this point, you know, we're trying to be opportunistic here, and if the browser supports it, then we'll assume that, you know, there's a good chance that HTML5 video will work. Next thing we check is, you know, can this video be played with HTML5 for business reasons? And really what this means is, you know, there's certain types of content that the advertisers might want to run against, and there's certain types of ads that perhaps we don't have implemented HTML5 yet, or other features that, you know, we haven't done yet. So that would actually preclude HTML5 playback. So you might have seen that if you tried the HTML5 player, sometimes you may actually fall back to Flash even though you were expecting to get HTML5 video. And this is the reason for it. Is typically, you know, we haven't actually completed all the features, and that's why you end up with Flash video, or the transcode does not exist for the format you're trying to access. And if it all works out, then, you know, you get HTML5 video, which is good. So next, let's chat about performance, and you know, this is obviously very important to us. So we look at, you know, several different characteristics. First, player start time. So when you embed a video, navigate to that page, how quickly will something start happening? For example, you see the spinner or something like that. And here we observed that HTML5 video was actually a little faster. So about 200 millisecond delta between HTML5 instantiation and Flash player instantiation. So largely driven by the plugin latency and so forth. So I mentioned before, HTML5 is more of a vertically integrated solution. So that was good. Next, we looked at, once you embed the video, and we actually fetch the thumbnail, like how long does it take for the thumbnail to appear? Because that's really where your user will see, oh, there's a video on the page. They actually can see the thumbnail. And this is where HTML5 was, a lot faster. These times here are exaggerated, but kind of the proportions are about right. So from the minute the embed is actually navigated to and the thumbnail is displayed, we saw a significant improvement using HTML5 video as opposed to Flash. Next test that we ran is, we call it get video time. So this is really equivalent to setting the source attribute in the video element. So we ran all the state machines, we figure out what format is needed, and we're about to start the video playback. And here, typically HTML5 is faster. We look at a bunch of different browsers. Opera 11 has actually done especially well on this test, and with Flash, IE9 and Opera were also doing quite well. Other than IE9, all the other browsers did better on this test than with HTML5 rather than Flash. So that also looked encouraging. The only one that didn't look so good is video start time. So this is really you embed it, user clicked, when do you actually see the video? And that's ultimately what we all care about. And this is where Flash clearly outperformed HTML5. So if you have an embed, player initialized, the embed is being shown, somebody clicks, how soon will they see a video? So there was a significant delta, and we were trying to understand what was driving this. What we thought is that one of the things that could be driving this is we are not getting as much HTML5 video playback on YouTube as we are Flash. So we are not taking advantage of some of the caching that we can do for that content with HTML5 versus Flash. So that's one possible explanation for that. But ultimately, this is an important metric, and Flash did better. So why is Flash fast? One lesson that we have learned implementing our Flash player is that it's good to make assumptions, and I'm sure you do that in your own code. So here's a couple of the assumptions that we have made. Firstly, most of our users actually have the latest version of the Flash plugin installed. And then we have a user population that has the older plugins. So what we have done is we assume that in our player implementation and then run with it, recover if that is not the case. So rather than trying to kind of check and then pick the Swift that is optimal for a given plugin, we make an assumption that the user will have the latest version and then do some level of recovery otherwise. And that has actually yielded 250 millisecond improvement. Another thing that we do is basically cheat. So for those of you that have kind of worked in networking, you might know that DNS resolution is something that is oftentimes quite slow. So it kind of takes a while to figure out what's the name to the IP address mapping, and when we actually fetch the video, that resolution needs to take place. And because of you can kind of be in different geographic areas, the actual name and the IP address may be different, so that the content is close to you. So that's important for our player. So what we do here is we actually try to cheat, and we set the source on an image to the video URL, and that'll actually prompt the browser to go ahead and start the resolution process while the rest of the player is loading. That was, again, 200 millisecond improvement. So embed performance is also very important, because ultimately, if you're using web embeds or mobile web, that's the user experience that people see most frequently. We also went through a kind of evolution of our approach to the player. Started with something like this. So as you see, there are actually 3 discrete steps required in order to actually play a video. So first, we would access a URL, which would perform a redirect. Then we would load a SWIF in the second step, which is a loader SWIF. That SWIF would load the actual player. So 3 steps involved. We improved it by going to 2 steps. So the first was actually a loader SWIF, and the second was the actual player. And finally, what we arrived at is something like this. And you see that with the iframe embed, where first we fetch a bunch of HTML. Then we decide, is this going to be HTML5 or is it going to be Flash player? And then we load a single SWIF. So that has also improved the performance. Another approach we took is to load lazily. So one thing that you might know is that most embeds are actually never really played. So people watch the site and navigate, but they don't click on the video. So that's another optimization that we have done. We delay queries that are expensive. So rather than doing things up front, we do it upon user action. We use cache whenever possible. And lately, we've been experimenting with actually delaying loading of the Flash player itself. So if you look at these 2 screenshots, you can't really tell which one is which. Is one HTML5? Is one Flash? Do you really care as a user? Probably not. So what we've been experimenting with is basically only loading the player upon the user actually clicking on the play button. So that's when the whole Flash machinery gets instantiated and run. And we've done some experiments with this. Some of them look pretty promising. So let's look at a little demo. But let me just use, I'm going to use Safari since we're talking about HTML5, and just to prove that this is a platform independent technology. Yeah, so what I have here is actually I navigated to a page which has 2 embeds, and the bottom one is HTML5, and the top one is Flash. And as you see, as I mentioned before, HTML5 loads a little faster. So now we have both embeds. And if I hit play video here, we actually starting playback through the player API on both of these embeds. Not nice. Okay, I guess my connection just went down. Let's try it again. Yeah, that's the thing about YouTube talks. It's kind of difficult to do it without very fast internet access. Let's try it again.
Hi, everyone. My name is Steve Chen. I'm one of the...
Yeah, so the Flash player actually picked up the
Hi, everyone.
The video stream first.
My name is Steve Chen. I'm one of the co-founders
so
of
that's,
YouTube.
It's not always reproducible in this order, but typically,
and I run the engineering team here.
Typically, that's what we've been saying. We run this. We have what we've been seeing. We've run this test, over and over again, and the actual video playback with the Flash player was a little faster. Player API. So, one thing that we have really looked into is, how do we offer a player API that works well across different video technologies? Because if we abstract out the embed syntax, how can we actually still offer the API to developers so that they can customize the player behavior? And we looked at a couple of options. The first thing that we looked at is using the URL fragments to communicate with the actual embed. There are some issues with it, though, that the messages would be unidirectional as they are with the fragment. So you can read the fragment, you can set the fragment without forcing the browser to navigate somewhere else, which is cool. But in order to actually read the player state, you need to do polling, and that is slow and eats up the CPU. So that wasn't very very attractive. What we decided to do instead is use post message, and this is something that was actually mentioned during the keynote. I don't know if you guys saw the demo with all the different tiles that were shown during the Chrome part of the keynote. They were also using post message. And what post message allows you to do is to basically send JSON messages to different windows. And it doesn't involve any polling. You can register an event listener to actually be notified when a message comes in. And communications is sandbox, so it's pretty safe. The calls are asynchronous, so all the send-receive stuff has to be done asynchronously, but that's pretty typical with JavaScript. And also we are able to have, say, multiple embeds, and you can call methods on multiple embeds, so kind of multiplex, demultiplex these messages pretty easily. So that was pretty nice. And here's what it looks like. So if I navigate to a page, yes, I created this video using an application that we have on youtube.com/create, lets you create your own animations. And what I did is I actually used the API to embed the video kind of like this. So the embed syntax is slightly different from what you saw previously. Actually, this uses the JavaScript API to instantiate the YouTube player, load a video. So this is the video ID. It registers a couple of event listeners, on player lady, on player state changes, and as soon as the player is initialized, it calls play video. So this allows us to offer the same API regardless of which player are you using, whether it's Flash, whether it's HTML5. And then the way it works is there's a JavaScript library which you load, and that's happening in this step right here. That JavaScript library sends a message to the actual iframe embed using post message. So this is the kind of asynchronous message communication. And then it's kind of easy to explore and see what methods are supported and so on. So if you want to play around with it yourself, you can use Chrome console and see all the operations, invoke them from the console and so forth. So that worked pretty well for us. So in conclusion, because of YouTube's requirements, we still mostly prefer Flash. We have some features that are critical that HTML5 player doesn't implement yet. The reach is still much larger, despite the great adoption of the modern browsers. Most of our users are not necessarily developers like yourself. So HTML5 is pretty awesome. It improves every day. On mobile platforms, for example, iOS, HTML5 is pretty much the only game in town. So if you're building an application, if it's a web application, and you would like to offer that application to mobile users, then there are many platforms where HTML5 is the only game. And unless you actually use the iframe embed and use the iframe API, then you're gonna end up in trouble. And people do want it. I think we have a lot of interest in HTML5 technology. And then if you haven't, if you like to try out YouTube with HTML5 and you haven't, if you go to youtube.com/HTML5, you can actually join the HTML5 trial. And what that will do is, whenever possible, you will get the HTML5 video with your desktop browser. The way this is implemented today is it actually uses a desktop cookie. So you get a cookie, and then as long as that cookie is present, it will actually serve HTML5 video to you. So today this is opt-in. By default, users will get Flash video. If you opt in into HTML5 trial, it will be HTML5 video. However, the way we implemented the actual embed, it uses the iframe syntax. So we can actually switch that at some point to HTML5, if we desire or whatever, for specific platforms, without you having to do anything. Another thing we're doing right now is if you use the embed, we actually starting returning. We'll be returning the iframe embed rather than the old AS3 embed, so that the actual embed syntax is kind of portable. And so this is pretty much it. We have a few minutes, so if you guys have questions, I'll be happy to answer them. And then, I have a couple of Twitter handles here, YouTube Dev is where we tweet. You can subscribe to this if you'd like to know kind of what's going on. And WATIC is my own handle, so you can ping me as well. Questions, please.
What about HTML5 streaming?
Yeah, that's a very good question. So for live streaming right now, on the desktop we support Flash. And there's a session actually about HTML5, about video streaming that I'm doing tomorrow, where we're going to discuss that in some more detail. What we're planning to do is to support HLS for HTML, HLS, which is HTTP live streaming. So this is technology that Apple developed, and it's being standardized. I think they submitted that to IETF.
How do you write that?
HLS. Yeah, HTTP live streaming. So in fact, if you go to our mobile website, m.youtube.com, on an iOS device, for some of the live streams today, we will actually already be using HLS. So some of the live streams on YouTube are already working on platforms that do not support Flash with live streaming. What we're working on right now is the iframe embed that I showed you. Today, we don't support HLS in that embed. So we supported it on m.youtube.com, but not in the embed. So Greg is actually implementing that right now. So the developers that want to embed live stream in a web application that runs on a platform which does not support Flash will still be able to do that. So that is something that is in the works. Maybe let's take another question and then come back, if that's okay. Uh-huh.
So, as a tablet user, sometimes some videos on YouTube are not supported. They say that it's mobile content, but tablets are not really smartphone. How that works?
Yeah. So the question was, sometimes you use a tablet and you want to watch a video and it's not available, and the explanation given is that, this video is not supported on mobile. First of all, I agree that the user experience on a tablet versus mobile is very different, right? I mean, that's why it's so hard to write a good app that will work really well on both, and you really have to think about the user experience. The way this works on YouTube is we don't really have control over which platform's content is available on. It's something that the content owner decides. So remember, I mentioned earlier that we are a technology company, and what we do is we pretty much enforce the rules that the content owners set. One of the reasons why, say, a content owner would not want a video to play on a specific platform is if monetization is not available. So say, if they're not getting paid, say it's music label or whatever, they're not getting paid, they may have a little less incentive to make that content available on a given platform. So that is really one of the limiting factors. So if, say, there's no technical issues, say the transcode is available, because that might be another concern. Like some of the older content may not be transcoded to a format that is only supported by a mobile device, so then it will not play. But then on top of that, the content owner can restrict which platforms are actually supported, and that typically is the reason for that. So I think as we actually implement more and more features in HTML5 that are equivalent to what you see in Flash, say the ad formats and so forth, monetization, then you see more and more content on mobile devices, both tablets, mobile phones. In fact, recently we added monetization support to our mobile player on Android, and a lot of the music content became available. So for example, Vivo content became available on Android with the YouTube mobile application, thanks to the work that the team has done on monetization. So that is typically what's driving it.
And something more about that. This happens also on Linkback. If you try to use Linkback and you use the remote for Linkback, sometimes videos are not appearing on Android devices. So you have playlists or
Yeah.
and you're not able to play those videos
Yeah.
because
Yeah.
you're using the remote from the Android device.
I see. Yeah. Yeah.
This is
Yeah. 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 Unfortunately, this is something that obviously I'm frustrated by this as much as anyone else. But on the other hand, I do respect the business models that the content owners have, right? So if they feel like this is not something they want to do right now because of whatever strategy that they pursue, then we will gladly enforce it because ultimately it's their content and that's how the site works. So really, the way we wrote the site is we're trying to enforce the content owners' rights to the extent that we possibly can. And even if you upload your own videos, you can set flags, like you can disable embedding on your own video if you like. So that's really, it may annoy your users, but for whatever reason you decided to do that and it's your content. Thanks. Any other questions? I think you had a question, we can go back to it.
I'm curious about how do you put ads in an HTML5 layer?
Yeah.
I'm not talking just about pre-rolls, I'm talking about the, how do you call it?
Overlays.
Overlays,
Yeah.
stuff like that.
Yeah.
It's that.
Yeah. So yeah. So the way our player works is if you look at the embed syntax as an iframe, and so we don't actually use the video tag directly. So when you or in other words, we don't allow the embedder to use a video tag and specify the URL of the video. So in HTML5, if you want to embed a video, you say video source, format, say MPEG-4 or WebM, and then the video URL, right? For YouTube embeds, you use the iframe embed, and our player actually is the one that will implement the monetization. So the monetization part, ads or whatever, pre-rolls, post-rolls, whatever it might be now or in the future, is something that the player does. So similarly, say annotations is another feature that is available with Flash. So those are the links that you can add as a owner of the video that will let one navigate to another part of the video or navigate to another video. That is something that we have re-implemented in HTML5 by combining overlaying those elements on top of the HTML5 video stream. So that's one of the reasons why on YouTube, if you want to use the YouTube video, you're welcome, but you use the embed YouTube player, not the actual raw video streams, because that allows us to implement features such as accessibility, monetization, all the good stuff that makes the site actually work as a business. Another question.
How soon do you think HTML5 will be at the same level as Flash in talking about the features?
Yeah. So that's it. The question is, how soon will HTML5 be at the same level as Flash? So there's actually kind of two buckets. One is, the browser support. So for example, one of the things that we found was missing is, direct access to your microphone and camera, so we can, do the video upload, right? Because that's another thing that we support on YouTube. So that will probably be a while to do in a platform kind of independent way. For our features, obviously the Flash player has been around for a lot longer, so there's still a lot of kind of functionality that we don't have in HTML5. But the basic stuff is kind of there. So if you look at, say, captions is something that didn't used to work several months when we gave a similar talk. We didn't have captions. Now we do. Annotations were not there. They are there. Monetization is another thing that obviously it's an area of active work, so we can bring more content to HTML5 platforms. So that is actually growing quite rapidly. But there's technologies that are missing in HTML5, such as secure streaming. So that is not even a part of the standard. So, and it is obviously important to some of our content owners. So depending on the platform, for some platforms it will probably be a while. For other platforms, it is there now. Because if you run YouTube on your mobile device that happens to run iOS, with the iframe embed, we actually are using HTML5 video today. We've made some good progress, but to a certain extent, we are limited by, the standardization efforts because we, support the variety of browsers. We are YouTube, so, we like every browser as long as it will play video. So that is another thing that is a limiting factor. So I think it will be a while. Yeah. Let's see. Okay, we have 2 more minutes, so maybe time for one more question. Please go ahead.
You're talking about early in your presentation about accessibility
Yeah.
with the tab.
Yeah.
Which disability is that to fulfill? I mean, if the video has something like closed caption or high contrast configuration for colorblind people, can you achieve that with HTML5 layer?
Well, I think there's the particular case that I was describing is like if you can't use a mouse,
But it's not for disabled people.
Well, I mean, whether that's a disability, it's something, but it's a valid use case. The keyboard navigation actually helps. What we have seen is, say, if you are visually impaired and you use keyboard for navigation, you can actually have text to speech. So say you could listen to the video. You have text to speech, and then you can navigate through the elements. We actually, I think, had a talk about that on at Google I/O. So then the various elements are actually transcribed, and that's another thing where HTML5 does a pretty good job because they're all HTML5 elements, and you can tap through them. So that's another example where the accessibility of the HTML5 approach is greater.
Okay.
Yeah.
About the other people with, deaf people or colorblind?
Yeah, so we do have, so captions is actually a good example, although there is no clear advantage of one versus the other, right? We support caption subtitles on both Flash Player and HTML5 Player right now. Yeah. All right, well, thank you very much. I think we ran out of time. Thank you. And I'll be around after this, and I'll be here tomorrow as well till the end of the day. So if you have any questions, grab me, ping me online. I'll be here to help you out.